I thought that on this section, section 8.3, I would spend one video showing you three different types of problems, the types of problems that I think we should be concerned about for the fourth test and also for the final. And so in section 8.3, you're going to see, like I would say about five different kinds of problems, but we're going to focus on three, okay? And so the first one would be a problem that comes to you with a formula. This also happens at the end of the chapter after we're done studying parabolas, and there will be these max-min problems to think about as well. So that's the vast accumulation of types of problems we see in chapter 8. And we've seen them before. The first kind, to get right to it, are problems that come with their ready-made formula. Okay, so I'm going to grab a problem that I'm just going to steal three problems from the textbook and take a peek at them. Okay, so suppose in this problem right here, suppose that the annual profit in thousands of dollars for a company can be predicted by this particular model. P of t is equal to 0.3 t squared plus 4.8 t minus 9, where t is measured in years. So you got a function that has profit in thousands of dollars to years, okay? It says estimate the time for the company to break even. Now, if any of you guys are going into business, that's a big deal. And I think we've talked about break even before, but that is when the profit is equal to zero, because what it's going to be is cost equals revenue. And what we don't know, but maybe we do, profit is equal to the revenue, the money you take in, minus the cost. And if these guys are the same, that means you broke even. You haven't made any money, you haven't lost any money. So we set the profit function, P of t, which is 0.3 t squared plus 4.8 t minus 9 equal to 0, and we solve for t. It's going to give us an answer for t. Now t, remember, is time. Okay? This is where the quadratic formula is really handy. In fact, all three problems we do, I hearken to the quadratic formula to help us out. That's from the previous section. Okay, so for this one, what you would do is you go, well, okay, if I'm setting this equal to 0, I want to say t is equal to, and the way I was doing it was I was going plus minus and then the radical over plus minus over the 2a kind of thing. Now remember, you're supposed to hunt for A, B, and C and plug in. So the first one is minus B, which is minus 4.8, all over twice A, which I decided to call it 0.6, and then plus minus over 0.6 also, the B, which is 4.8 squared minus 4 times A times C. Now C is a negative 9. Don't make those mistakes of past students of forgetting the negative on that. Okay, so in this problem, what I got was this ended up being negative 8 out in front, and then plus minus, when you do that math, I got about 9.69 roughly. Okay, there are two choices here, you guys. One is to say t is equal to minus 8 minus 9.69, but this is negative. And I'm thinking in time, that won't do. But the other choice is minus 8 and then plus 9.69, which gives us an answer of 1.69 roughly, or about 1.7 years. There, that problem is done. It'll take 1.7 years to break even with this company. Take a while. They put in a lot of money up front, and then they make money, and finally they're breaking even, and that's a special day. Okay, that's one. Okay, you ready to move on? We'll move on to the next one. This should look familiar. It's someone that's driving somewhere, etc. So I look at it, oh, okay. Right away, I don't know about you, but right away, I'm going to go rate times time equals distance, okay? And get this thing going on. Okay, let's read the problem now. This is problem number 44 from the text. Kathy traveled from Red Rock to Phoenix, which is a total of 300 miles. After her drive, she figured out that if she had driven 10 miles per hour faster, she would have arrived 1 hour earlier. find the average speed that she drove. Okay, so that she's thinking if she drove 10 miles per hour faster, okay, so let's say that this is the slower trip and this is the faster. We know the distance either way is 300 miles, right? The slower, here we're going to insert a variable. I don't know how fast it is. In fact, that's the guy we're looking for. Okay. But if she had gone 10 miles per hour faster, and I write that this way, you would too. That's her speed. She's going 10 miles per hour faster. She would have been there an hour earlier. Okay, so now here's the tricky part. You ready? Here we go. Time is distance over rate. Time is distance over this rate. Those are the times. Okay? Now, they had something to say about the time. This guy here, slower, I'll write it over here, slower and faster trip, as if in her mind she did a faster trip, right? And she did some math. She goes, doggone, if I had gone faster. Okay, so what is she figuring out? The time, 300 over x, right? This is the slower time. And then the time, 300 over x plus 10, is the faster time. Okay, so, but how do they relate? Okay, this is faster by 1 hour. Okay, so either they're not equal to each other. One is one more than the other. Okay, so either you take the slower and subtract an hour, or in this case, what I did is I went, if I tack on 1 more hour to the faster time, it'll equal the slower time because they differ by an hour. Some people say slower minus faster equals 1. You see it in different ways. But this is how I would set the problem up. So setting the problem up is half the battle. What we do next is we come in and we do the usual, let's clear fractions on both sides. So we're going to multiply each of these guys by, let's see, look at the denominators. X times x plus 1, x plus 10 on both sides. And don't forget this 1 is just over 1. So we go ahead and we distribute this thing, and we end up with, on this side, 300. The x's cancel, and you have x plus 10. On the other side, the x plus 10 cancels, and you have, over on this side, 300 times just x. And then finally, the 1 meets these guys, and it's just x times x plus 10. And lo and behold, it turns in quadratic on us. So cleaning up, yeah, you got to go with the numbers. If you're doing it right, you learn to trust the math. Do I know I have this right? Pretty much from experience, but as a student, I would be more, boy, I hope I have this set up right. Okay. Because we have a quadratic, see the square here? We have a quadratic. What we're going to do is put everything on one side. I'm going to create a 0 over here. And to do that, we're going to go, let's get u out of there and subtract 300x. And look what happens. It's all gone. And then minus the 3,000 over here. And we end up with a quadratic that says x squared, I think, plus 10x is minus 3,000 is equal to 0. And so lo and behold, another quadratic, right? Good problem. You know what the quadratic is good for? For those days when you look at a problem, you go, I don't want to try to factor that. So I don't. I just simply run the quadratic formula. This time we have a is 1, b is 10, and c is negative 3,000. So we're going to plug those numbers into this guy. So it's going to be minus 10 over twice 1, which is just 2, plus minus the square root of stuff over 2. By the way, this thing inside here, and I didn't mention in one of the meetings, or one of the videos, the last one, this is called the discriminant. I don't really look for it much, but basically, if you look at it, the thing that's under the radical, you can tell if you get 0, there's one answer. If you get a positive, you get two real answers, and if you get a negative, you get two complex answers. To me, it was so unimportant that I just ended up forgetting to cover it. But anyway, when I was doing the quadratic formula. So we take the square of b, which is 100, and then we go minus 4 times a, which is 1, and then watch, negative 3,000, okay, is our deal. So in this problem, when I used the calculator, I got a minus 5 here, but then it became, all of that just became plus or minus 55. It was a nice one, and it would have factored, as it turned out. So you have two choices. One is minus 5 minus 55. That's how fast she was driving? Backwards? No. So this is standing for her speed, remember. And we don't like a negative speed. So we go, the other route would be the 55 positive and then minus 5. It looks like what we found out in this table, that was the original speed she was driving. And so the story is this. She traveled, on average, 50 miles per hour on her trip. And she realized that if she went 60 miles per hour, she would have gotten there an hour sooner. There's a story behind all these word problems, and that's Kathy's story. And finally, rate of work. Rate of work. Okay, so let's read this one. This is problem 52 from the book. Of course, you can pause it. You can go back up there and look at that and study it. A small heater takes 6 minutes longer to raise the temperature in a garage to a comfortable level than does a larger heater. Together, the two heaters can raise the temperature of the garage to a comfortable level in 42 minutes. How long would it take each by itself to raise the temperature? Okay, so with rate of work, I just go, hey man, how long were they working together? 42. Usually we're looking for that number, right? But in this case, we don't know their times. All I know is that one of them, this guy say, takes 6 minutes longer than the other guy. So if you're comfortable with rate of work problems, you just set one up, you got half credit right there. Believe it or not, in my class, that's what you get. You set it up right. Now it's a matter of solving, so we come along as usual, and we're going to multiply both sides by, the thing, the thing that'll cancel everybody, and what it is in this case is x plus 6. So that looks similar to the last problem. Okay. When we distribute, in the first case, x plus 6 disappears and we're left with 42 times x. In the second, the x disappears and you're left with x plus 6. And lastly, nothing disappears because it's just over 1. It's 1 times it, so you have x times x plus 6. Very similar to the last one with Kathy. Okay, so we start solving. So multiply out this little guy here, 42x plus, and that guy was 252, I think, right? 252. And on the other side is x squared plus 6x. So we have 84x plus 252 is equal to, over here, x squared plus 6x, and again, it's a quadratic. So as I was talking a while ago, ZFS, get 0 on one side, we will. And the way we'll do it, of course, is subtract that 84x away. And also the 252. Okay. All right, so 0 is equal to x squared. This would be minus, we're minus 78, right? X, and then minus 252. And once again, man, I don't want to factor that. Turns out it doesn't anyway, because look, I got this. I ended up with a minus b, which is a minus is positive 78, over twice a, which is 2 times 1, plus minus the big radical over also 2. And in here we have minus 78 squared, minus 4 times a is 1 times c is negative 252. One little sign will mess you all up, so be sure to get that right. On this side we get a 39, plus and minus, and with the calculator I ended up with, I believe, I hope I made the right number here, roughly 42.107. And you see the pattern of these problems? So one of the answers X. Now what does X stand for again? Oh yeah, the time. Let me look up here again. It's the time of the faster heater. The slower one, you have to tack on 6 more minutes for it to do the job. So when I did this, of course, I'm not going to go 39 minus 42.107. That's negative. So that's not really a sensible time. So really, we would go 39 plus the 42.107. And for that one, I got 81, roughly I said 81.1, and I would say minutes for the faster heater. And then if you tack on the 6, you go, all right, plus 6 gives us 87.1 minutes for the slower heater to heat the room, to heat the garage. Okay, there you go. That's how it's done here. The quadratic formula was used each time. It's handy. All right, we'll see you in the next section.